All right, let's look at example 3. Let P be you are a guitar player. That's my P. And Q be you are a musician. Write each statement in words, then decide whether it's true or false. So first, let's write the conditional. If P, then Q. So we'll just do the regular order. If you are a guitar player, then you are a musician. All right, and let's think about that. If you play guitar, are you a musician? I would say true. All right, now let's do the converse. I should have color-coded this. All right, we'll do that starting now. So the converse means you're changing the order. So Q goes first, you are a musician goes first. If you are a musician, then you are a guitar player. Now, to decide whether there's something in math is true or false, it always needs to be true, so not sometimes. So if you are a musician, then are you always a guitar player? No. You could be a drum player. You could be a violin player, so that is false. Yes, you could be a guitar player, but you could not be, so that's false. So just because a statement is true does not mean the converse is true. All right, the inverse. Remember, for the inverse, you are making them both negative. So you're not changing the order. So the original order will stay. If you are not a guitar player, then you are not a musician. Okay, so let's think about that. If you don't play guitar, does that mean you're not a musician? I would say no, that's false. You could be a drum player and yes, be a musician. So this is false. Oh, good, we have people doing their homework. All right, for the contrapositive, you're changing the order and you're changing if you're making it positive or negative. So if not Q, then not P. So Q up here, Q is you are a musician. So if you are not a musician, then you are not a guitar player. Let's think about if that is true or not. Okay. If you are not a musician, if you do not play music, is it true that you do not play guitar? I would say yes, that is true. And remember, we said earlier in the notes, the contrapositive always has the same true falseness as the original conditional. So those are both true. So if you need to, pause the video for any more time. So, okay. Number 4, write the definition of perpendicular lines using a conditional and the converse. Okay, so perpendicular lines, if you've forgotten, perpendicular lines form at 90-degree right angles. That's perpendicular lines. So let's start. If lines are perpendicular, then they intersect at right angles. Okay, and you could say this some other way. You could say they form 90-degree angles when they cross. Okay, it doesn't have to be exactly this. Then let's do the converse. Remember, converse, you're changing the order. So if lines intersect at right angles or intersect at 90 degrees, then they are right angles. Now, it doesn't ask, but it's going to come up in the next slide, so let's just talk about it briefly. Are these true or false? This is true, right? If lines are perpendicular, they make right angles. If lines intersect at right angles, oops, I just wrote that totally wrong. Then they are perpendicular. Sorry about that. So sorry. Not paying attention. Clearly. Okay, very well. That is also true. Okay, and we're going to talk about a way to kind of combine these two, the way to combine a conditional and its converse, because that was kind of a lot of writing, right? To write out two sentences if they're both true. So is there a shortcut? So remember we said here, if lines are perpendicular, they intersect at right angle. Yes. So please make sure you write down this vocabulary word. It's called a biconditional statement. Biconditional statement. Okay, so you don't need to write every single thing under core concept. What does it mean? It means a conditional and the converse are both true. Okay, it means the conditional and converse are both true. Okay, so if that is the case, kind of like with perpendicular lines, then we can write what's called a biconditional statement. It has to use the words if and only if to be a biconditional. And then you'll want this. If P, if and only if Q, and then the symbol is like a line, two arrows, because you can go back and forth. Okay? So, rewrite the definition of perpendicular lines as a single biconditional statement. So, let's go ahead and rewrite that. So, lines are perpendicular if and only if, perpendicular, because remember we need to use that language. They intersect and form right angles, or 90-degree angles. Okay, so yes, it's still a sentence, but now I only have to write one instead of two. Okay, and I have to use if and only if to make it a biconditional statement. All right. So example 6, we're going to do one more biconditional and then the summary. If, and this is true, if you can run for president, then you are at least 35 years old. So that's the if then statement. The converse, if you are at least 35 years old, then you can run for president. So let's change that into a biconditional. So you can run for president if and only if you are 35 years old. Which is true, and in the Constitution, I didn't make that up. I didn't decide that, but that is something that is true in the U.S. All right, summary. What is a conditional statement? What are the parts? So talk about the hypothesis P, the conclusion Q, that it needs to be written in if something and then statement. Okay, then you're going to use the phrase snow is falling, it is winter. And you're going to make a conditional, a converse, an inverse, and a contrapositive. Lastly, what is a biconditional phrase? The if and only if stuff we did in examples 5 and 6. Okay? So the summary will be a little bit longer today, a little bit more writing. The nice thing about the homework is that you'll just get to choose. You won't have to write out by hand all those statements. All right, if you have questions, email me or join a Google Meet.